Hello, so my name is Richard Caetano. I'm the CEO of Stratumn, and I'm with Anuj Gupta, the VP of Research at Stratumn. And we're going to talk about proof systems and and share with you the research that we've been doing and how we can take systems like past just the idea of decentralization, but also past the idea of like client-server and looking at new models to build trust. So first of all, I just want to start with a review of the very, very basic proof system and what does it mean and how does it apply. So in the model, there's a prover verifier, and in this model, the prover convinces the verifier of a statement about reality or a held secret beyond a reasonable doubt through a protocol exchange. And so by modeling around the proof system, we can find new ways to architect systems. So if we look at, we've got this kind of thing going on. All right. So if we look at the original Bitcoin system, we can find some examples of this pattern, and especially, more importantly, how the pattern is interchangeable within the system. So just to point out, in this sense, you have a prover sending a Bitcoin to the network, which is the verifier. And so the prover is trying to convince the network via digital signature and like the double spending amounts. And then in the same case, the verifier, which is the network, becomes a prover in another case. And the network, through confirmations, is proving to the verifier, which is the receiver of the Bitcoin, that they control the coins. Another example of this is also the miner. Like the miner is proving to the network that, hey, I've solved the proof of work problem, and this, convincing the verifier allows the verifier to award new Bitcoin. So in here we can see like the prover verifier model being interchangeable, and we can see how it comes together to create like the blockchain system. And so building on this, I'm going to let Anuj talk a little bit about a proof matrix that he developed.
So in the proof matrix, as you can see, so every proof is talked about in two ways. One is the construction of a proof. For example, if you're proving you are who you are with digital signature, so you construct a proof with a private key. Another is the actual verification of the proof. Now, the construction of the proof is not symmetric to the verification of the proof. Construction might take shorter time, long time, but it doesn't mean the verification will be symmetric, right? So in this perspective, if you see that the proof construction can be about, you're constructing a proof about what should happen in the future. For example, in a smart contract, which has an external input, you are basically saying that if so-and-so logic happens, if someone provides some kind of data, if two people agree on something, then the network can verify either objectively, so which means that whatever data is inputted to the smart contract can be, say, computationally verified, so it's an objective verification, or the smart contract can take input, say, from an oracle. In that case, the network has to, the consensus has to basically trust the subjective source, the oracle, or whatever is the case that you are inputting, right? And similarly, if you are constructing a proof based on what has already happened, so you are proving what happened, not what should happen. So something like, for example, in a proof of work, so you did a computation to solve a puzzle, and then you are proving to the network, based on what you did, the nodes that should match a particular answer to a particular puzzle, right? So a zero-knowledge proof or a proof of work is a proof of what happened. And the verification could